Okay, so hello students, good afternoon, and welcome to SolidWorks online training program at SaiCad Center. And my name is Setu Nandania, and I am a Autodesk, Dassault, and PTC certified instructor. And let me continue our today's session with the software. So here I am going to share my software screen. So I hope this software screen is visible for you now.
Yes, sir.
Okay, good. So first of all, we will create that parts that we given in the assignment. This one. I will begin with this one. So for this, we should have, or we should create couple of things. So first of all, we will create one line for the sweep tool, and then we will create one more line for the sweep tool. This one, right? So these are the two lines we have to create. And also the diameter, and also the diameter of this line is 40 mm outer diameter, and diameter for this line is also 40 mm.
43. 43 seems.
Okay, yes, it's a 43. Fine. So let we begin. 16 plus 4 and 143. Okay. So first of all, sketch on the front plane. Create one L section over here. Smart dimension, this one 146, sorry, 143. And then we have 40 mm radius plus 16 mm plus 4 mm means 20. So total 40 plus 20, 60. So this line should be 60, and fillet of 40 mm radius at here. Okay, and finish it. If you have a 2017 or above version, then directly just go to this sweep and click this circular profile. What is our diameter? 43, and this is our path, and hit finish. So this is done. Now next we have to create U shape, this shape, and it is we need to find out this distance, and it's at 60.
64.2.
Yes.
64.2.
So take a plane from here, distance 64.2 on the other side. So flip your dimension. So this is okay. And now create a sketch on this plane. We'll begin with a line like this, then here, then again here. And this point with this line should be horizontal. So let me take this point horizontal. Okay. So the bottom base level is we have given. Now here we have a continuous arc actually. So instead of this line we want arc, 180-degree arc. So select it and delete it. And now smart dimension, a diameter of that arc is 45.5. And then the length of this line is 65. So this one is 65. Is it 85? Sorry. So yes, clear. And finish it. And again click on sweep, circular, 40 mm diameter, this one, and hit OK. Right? So yes, that's it. That's much simple, isn't it? Or still you have any confusion?
Sir,
Yes.
when we are making that intersection, when we are making it within feature, that part is protruding inside that hollow, sir.
But why are you creating thin feature? I know that
So leaving,
it is not possible to create this thing with a thin feature. That's why I taught you this shell command at the end.
okay, sir.
Right? That is why that this is the only reason. That's why I taught you this shell command.
Okay, sir.
Right? And today we are going to discuss this thing in detail, that how this shell command exactly works. So let me finish this thing first, and then again one more sketch on the bottom. Again control it, and I want like this. So the diameter of this circle 105, 80 mm. Okay, so circle, and here, and one should be here, and the diameter of this one 105, and this one 80 mm. Am I right?
Yes, sir.
So why we have this much gap over here? Okay, actually we provide radius instead of diameter. Sit. Let's go to this sweep 2 in the sketch. See, we have radius. Delete it. And again dimension from here to here. This is 45.5. So the diameter of this thing is 45.5. Now it is correct. Again, let me go to the sketch, control 8, and trim tool, trim this thing, fillet of 8 mm radius. Okay, and one line tangent to this both circle. Select this, click tangent, and trim this geometry. Okay, finish. and go to the extrusion. How much? 10 mm. Flip the side 10 mm and OK. Okay. So just I'm going to save this thing up to this point. Close it. And now begin with the blower. So now give me the suggestion from where we should start. So we will start with the cylindrical geometry that we have 68 mm diameter. So click on extrude, not on this face. We will take on front plane. Circle 68 mm diameter. Actually these dimensions are wrong, right? Actually you just focus on the dimensions. 68 mm diameter, that means nothing. It's a very tiny object. So assume the overall dimension of the blower, right? It's not bigger than your finger. So these all actually dimensions are in inches. That is why. Or maybe in centimeter, but it is actually not mentioned over here. So we will continue with the mm. It is fine. Now the extrusion of this assembly is again actually not given. So there are many dimensions are missing. So this is 38. So we are actually taking 40 mm height of the cylindrical drum. So
Down, sir. 42.
yes,
42. So yes, 42.
42. Yes, yes, yes. So you should tell me first, man. Okay, no problem. So this barrel is done. Now we have to create this geometry, this top geometry. And for that we have only one location, a location of this cross section. It is at 25 mm distance from the center, and from the top we have 57 mm offset from center to this top, right? So we have only this one, nothing else we have. So again create one plane, choose your proper plane. From front plane we will create a offset of 25 on this side. Okay, now create one sketch on this plane, not like this, like this. Rectangle. Okay, dimensions from this top face, from the center we have 57, right? That is given. Then cross section AA, where is A? I think this one, A, smaller cross section. So 40 mm by 24 mm. So this one is 40 mm and this one is 24 mm, right? 40, 24. Is it correct? Okay, let me check what we are getting. So one more dimension, this should be in the center. So this should be 20. And a center line over here, because the radius is also 57. So the center of the revolution will be here. Finish it. Actually, we missed to add these fillets. What are the values of the fillet? Do you find the value of these fillets?
Not not given, sir.
Not given.
Sir, I took them as 4, sir, actually. It was came as it is as the diagram.
I agree with you. Let me take 4. It's too small. 6. It is also small. 8. Okay, this thing looks like similar with this one. So 8 is enough according to my thought. You can take whatever you want, right? Because it is not given. Now take the revolve tool, select this axis, provide 90-degree angle, flip this thing on the other side and hit OK. So that's it. Then next we have a loft tool. So again one more plane at 67. So reference plane from the right plane, distance 67. Flip it. Okay. And here again sketch, Control 8. Rectangle, dimensions, this point from here 57 and cross section 48 by 35.
Sir, just a minute, sir.
Yes,
Sir, you gave control 8 and you got a normal view, right, sir? Then you just
yes.
flipped to another normal view. How did you do that, sir?
Again press Control 8.
Okay, fine. Thank you.
It will flip. Anything else? So here we will take a radius of 10. So fillet of 10 on this corner, this corner, this corner, on this. Yeah, fine. Now again go to the feature, one more sketch. So on this plane, right click. Okay, finish this sketch. Okay, we have loft. So click on loft. Profile 1, not this edge. Profile 1 is this face. And profile 2 is this one. And it is selected. Now see, over here we have to provide starting constraint. It should start tangentially over here like this, right? So go to the start constraint, normal to profile. Now see, it is good. or you can create a guide curve also, but uh, leave it like this. Now at the end, go with the shell, 2 mm thickness. This is open geometry, this is open geometry, and finish. Here we have our output. The rest of the thing is fine for you. Before this shell, actually add one more fillet that is given on the over here. It is not given. Actually, there must be. So add one fillet over here. This. Then go for shell. And that 16 mm diameter hole is over here. So now go with the extrusion cut here and create one circle of 16 mm diameter. Finish it and up to next. Okay, so like this is that hole. Sir, it's 35, not 38. Which one? Okay, this one. But you get my point, right? It is not necessary for me. Whatever we have, it is fine for me. But you have to create this thing. Well, that doesn't matter. Okay. But you should understand this thing, how to create it, right? So I hope you get the exact idea. So before we continue our today's session, let me check our today's assignment first. What we have new. Actually, I haven't seen that. Okay, so this is our SolidWorks assignment 4. So you have some new parts, some new industrial component, also component with some draft, rib and revolve, and some patterns. Okay, so this assignment is not much complicated actually. It is fine. So here I am to continue our session, our today's session. Okay, now do you have any questions?
No, sir. Clear.
Okay, understood everything? See, if you have
Yes,
any
sir.
question, then ask
Yes, sir.
me, right? Don't hesitate in asking the question.
Okay, sir.
Okay. So let me take a new file. And today we are going to learn our modifiers. So we have many things in the modifier. We are mainly going to focus on fillet, chamfer, shell, draft. So these are the tools that we are going to learn today. And there are many more things inside that tool also. So once you have a solid like this, and if you want to break this sharp edge and provide some smooth uh, corner over here, right? So for that we use fillet tool. In the sketch also we have fillet. Similarly we have 3D fillet. So click on the fillet, and here you will find four divisions, four types of fillets we have. First one is the constant size fillet, right? Or we can say edge fillet. Tell me about sweep. Actually now we will discuss that at the end of the session. We just started our session, right? So just remind me at the end. Okay, Ramandeep, it is fine. Okay, just remind it to me, right? So first we have edge fillet over here. So you just have to provide a edge like this. So you will get a preview and provide a value on, let's say 15, and hit OK. So you will get a fillet like this, right? It is so simple, so simple. Okay. But if you focus over here on the exact geometry, so it's a perfectly circular. So we have other types of fillet also. Again, fillet. I'm choosing this edge, and let me show you it from the 2D view. So this is our preview. But here, instead of symmetric fillet, I am choosing asymmetric fillet. That means it's our elliptical fillet. Here your major radius and minor radius we have. So let's say 20 mm is my major radius, and 10 mm is my minor radius. So see, here you will get a elliptical portion, right? Where we have a 10 mm minor radius and 20 mm major radius. So this type of fillet also we have, right? So this one that we generally prefer or use, and this one also we have. Similarly, in the fillet tool, it is actually selecting your chain. So once you choose fillet and you are going to select this edge, so it is actually going to select your entire loop like this, right? Up to that point where it is going to catch a corner, right? Whatever smooth edge you have, it will be selected. Because we have over here tangent propagation, so we are getting this type of result. But if you turn off that tangent propagation, this one, so your only this edge is selected, and you will get only that much preview or result, right? But just turn on the tangent propagation, because this will not fine or good for us. So let me delete all these fillets first, and now we are going to discuss our next fillet, that is variable radius fillet. See, for the first fillet we have a continuous radius. Whatever radius we are providing, it is actually continuous. Also we have some profiles over here. In the asymmetric you will get a elliptical profile, and in the symmetric you will get a circular profile or conic profile also. But that's it, it's a very simple thing. Let me go with the next one. We have a variable size fillet. Just select your one edge and you will get so many points on that. See, starting point, ending point, and in between we have 1, 2 and 3 points. It is visible to you also. Can you view this?
Yes, sir.
Okay. So here we are able to provide different types of radiuses. See, here we have variable radius unassigned. Double click on that, or you can provide value from this tree also, this feature manager tree also. So here I want 15 mm. So see, we started a 15 mm fillet over here, but up to the end I want 25 mm. So here we have a continuously varying fillet. Here we have 15 mm radius, here we have 25 mm radius, like this. If you want to add some new points, then just click on this pink bubble, click on that, and that point will be activated, and that point will carry two values, R and P. P means position and R means radius, right? So let me click on the radius, and I want 10 mm over here. So here 15, and then it is actually going to decrease up to this point and again going to increase. And this P value is the position, and right now it's 50%. So by percentage we can provide a position, right? So let's say I want this point at 60%. So see, he shifted over here. So once you shift your point, you will get another pink dot over there. But these pink dots are the deactivated point. Once you click on that, it will be activated. So here 15, then 10, then continuous 10 up to this point, then again 25. If I'm going to click on this point, let's say 20 mm, and the position should be 40%. So in this way you can add and remove, or for the removing point, just here we have list of the points, right? Just select that and right click and click on delete to remove that. Click on finish and you will get this type of fillet. So it is clear now, the variable radius fillet.
Yes.
Okay. Then we have a face fillet. In the face fillet we have two types of face selection, the third fillet, face fillet, and we have two types of face selection over here. A selection set 1, which is in blue color, and selection set 2, which is in pink color. So let me select two faces, this one and this one, in the selection set 1, and two faces, this one and this one, in selection set 2. So wherever you are getting a edge which is actually going to created by the set 1 and set 2, will get fillet, right? See here, these both are blue faces, so we do not have fillet over here on this edge. Here we have both pink faces, so we do not have fillet over here. Wherever these both faces are meeting or coming together. Only on that edges we are getting fillet, and fillet radius you can provide over here whatever radius you want and then finish. So it is almost similar with the edge fillet that we discussed, but in the edge fillet we have to select the edges, right? Whatever edges you want to fillet, and in the face fillet our selection method is different. And at the end, the last fillet we have, that is full round fillet. So click on fillet, and the fourth option is full round fillet. This is my first face, my second face, and my third face. So automatically you will get a full round over here, right? So it is actually a reference fillet, we can say. A tangent, tangent, tangent arc, it will be done. See from top, you will get the idea. So it's obviously tangent over here and tangent over here, and tangent on the third face also. So you will get this type of fillet. So value input is not there for this fillet. Just finish it and you will get a object like this, right? So these are the options we have for the fillet. Now one more option for the fillet at corner. So go to the fillet again, and let me go with the simple fillet, and here I am selecting, turn off this tangent, this corner, this edge and this edge, right? So we have selected these three edges over here, then click on OK, and you will get a corner like this. It's actually a spherical shape, right? But what if you want to change the parameter for this corner point? So again, right click and go to the edit in that fillet, and for the corners like this we have a setback parameter. So go to the setback parameter and select your corner point, and you will get three values over here. You will get the input of three values. So this is our setback parameter. For example, I want a setback in this direction 25 mm. So here 25. So see, it's actually extended up to this point. On the other side, let me take 25 in each direction. So your this corner, the curvature effect of this corner is actually stretched, right? So you will get this type of corner now, more stretched corner. So this is our setback parameter that generally we apply in the plumbing parts like elbow, T. So these are the components we have where we use this thing. Similarly, next we have a chamfer. So again, remove this fillet, and now chamfer. So go to the drop down of the fillet, and here we have chamfer, and actually there are so many options added over here, right? So first one is distance and angle, second one is distance and distance, and third one is for the vertex. So these three are the only useful and practical purpose options we have. So let me go with the first. Select your edge and you will get one arrow. So this is your chamfered value distance, let's say 20, and then angle, it's a 45, so it will be equal distance chamfer, and let's say 30. So see this new face with this edge, here we have 30-degree angle, and you will get a result like this. So this is our chamfer. There is one more method for the chamfer, that is distance method. So instead of angle, if you want to provide one more distance, so go with the D. So here if you want the both dimensions same, then go with the symmetric, but if you want both dimension difference, then go with the asymmetric, right? And one dimension is 10 and one is 20, so you will get a result like this. This is 10 and this one is 20, and then it is trimmed like this. Clear it is? And lastly we have a chamfer for corner vertex. So go to the chamfer, click on this vertex, click at the corner, and you will get three inputs on 1, 2 and 3. Okay, it is fine now. So in this edge, how much you want to travel, just type it here, 15, on this direction 25, on this direction, or type it over here. If it is difficult to select it from the screen, 30, and then finish it and your corner will be trimmed. So clear for the fillets and chamfer both. Hello students, are you there?
Yes, yeah, sir.
Okay, I need to confirm that you are there or not on the other side. Okay, no problem. So next we have uh, rib and draft and shell. So these are the tools we have that next we are going to learn. So let we begin with the draft next. Actually draft that we already discussed in some other tool. Do you know in which tool we discuss this draft?
Extrude.
Boss.
Yes, in extrude. So while extrusion we are able to apply taper angle, that draft angle, right? But what if you want to
Yes, sir.
apply a draft only on single face, right? So it is not possible in the extrusion tool. So for that we have a separate draft tool over here. So click on draft. But for the draft you will not get any preview. Go to the manual, and here we have three types of draft: neutral plane, parting line, and step draft. But you will not get any preview, right? Now for the draft, to draft any of the face or object, we need two things. One is draft angle and second one is hinge. Are you understand in the hinge? What is hinge?
Connecting two faces. Edge connecting two faces.
Hinge, that's we can say pivot point.
Yeah,
Pivot,
pivot point or center point.
yeah, center point or a rotating point, rotation axis, you can say, right? Hinge.
Yes.
Okay. So that hinge, the position of your hinge is very important, and that will be created by intersection of two faces. See, first of all, we have neutral plane draft. So here we need to define a neutral plane. That means fixed plane. So for example, this is my fixed plane, right? This pink one is my fixed plane. So whatever things on this plane will not going to change, are not going to affect with the draft. Now the drafting phase, let me select this one. So this is my drafting phase. So the intersection or the crossing point or the crossing line of our neutral plane and drafting phase. So this line is our pivoting line or center line or our revolution line, right? So just provide your draft angle and hit OK. Now just keep your eye on this edge. See, this edge will not going to change its position. Whatever changes is done over here on the bottom piece. This will remain as it is, right? So I hope you get my point. So the intersection, see again, the intersection of your neutral plane and your drafting face will be a line, right? And that line is your hinge, your pivot point, or you can say, let me increase this draft angle to 45. Now you will get the exact idea. So this face is actually going to revolve like this around this edge. See, it is clear now.
Yes, sir.
Okay. So what if I choose my, so the selection of neutral plane is very important. See, let me take draft again. This time I'm choosing my neutral plane. This one, right plane is my neutral plane, right? And I'm choosing drafting face, this one, right? So what will happen? My that pivot or hinge will be over here. Arbiter, you need to assume that intersection line of our drafting face and our neutral plane, right? So here will be our hinge and our drafting direction is this one. So whatever value we have, and let we have some 30°. So it will be affected on the both side of the neutral plane, this side and this side, but it will be reversed from the both side. See, so the hinge of this draft is over here.
Sir,
Yes.
can you repeat it?
Yes, see, I'm going to annotate this thing. We have this neutral plane right here, okay, and this is our drafting face. So the intersection of this both thing, that means you intersection of drafting face and this neutral plane will be a line, right? This one, and this line is my pivot point. So this line will remain over here and the rest of the face will revolve around this line. So this is our revolving axis, we can say, right? So as I am going to finish this thing, so this edge will all remains over here and the rest of the piece is going to revolve around this thing, whatever degree you are providing over here, right? or still confused? Okay, now again, explain with other plane. Okay, I am explaining you. See, neutral plane we are taking this one, right? And drafting face is this one. So the intersection of this neutral plane and drafting face is this edge. This edge is the intersection of this both face. So this edge will be our revolving axis. So what will happen? See, from this view, this particular view. So this is our face which is going to affect in our this operation, and this is our revolving point, right? So this face is actually going to revolve either in this direction or in this direction. So we have two solutions. For example, this face is going to revolve like this. So this is my new solution, right? It will revolve like this, in this way. But we need to extend it up to this face because we have a face on the bottom. So we need to extend it like this. So this is revolution outward. Similarly, if that revolution is done upward, then it will revolve like this, right? So this will be our revolving axis we have. So this is the degree and hit OK. So see, this vertical face is actually revolved like this, right? So the intersection of our neutral plane and drafting face is our revolve axis. But the direction of the neutral plane, see, our direction of the neutral plane is upward. So when you go upward, your draft angle will be inward, and on the other side our draft angle is outward. So if I change the direction of neutral plane, so now my direction is downward. So over here we have inward draft. So this you can simply say it's a flip tool. You can flip your degree outward, inward, right? So in this way you can flip. Now let we take multiple faces over here for the draft. So I have chosen this one also. So draft will be outward. So this face will take angle from this edge, and this face will take angle from this edge, because the intersection of the drafting face and neutral plane is our revolving axis, right? So you will get a solution like this. See, view it from here. So this vertical face revolve 30-degree outward, and this vertical face revolve 30-degree outward around this edge. Now it is clear. Okay, good.
Yes, sir.
Then next we have a parting line draft. So what is parting line actually? Parting line means that line which is actually dividing your face into two part. That is known as parting line, right? This is my single face, and if I create one line over here, so that line will actually going to divide my face into two part. So that we can say parting line. It is just a line like this edge, but this edge we cannot consider as a parting line because this face and this face both are different. So how to create parting line? Let me create one sketch on this face. Okay, so here we actually want to imprint this sketch on this face, right? So for that, go to the curves, and here you will get this split line tool. Click on this split line, go to the projection, and here is my sketch, and this is the face which I want to split it. Okay, now what exactly happened over here? We have a single solid, but this face is divided into two faces due to that split operation, right? So now we have phase 1 and phase 2. So this edge is known as parting edge, right? So let me add more faces, this one, and this one also. Okay, so these all faces are divided, but we have a same solid, right? Solid is not split. We just split this face. Now go to the draft, choose this parting line draft. Pulling direction is this one, and select your parting line. But let me select 3 edges first. Provide your draft angle and hit OK. So here your revolving axis will be your parting line, right? So whatever angle you have provided, we have 25 degree. So our parting line, it will take angle from our parting line in that direction, right? So let me select the other faces. Select this one also, this one, this one, this one, and this one. So in this case, our draft angle is taken from the parting line, right? But we have exactly a reverse solution, and that is step draft. So go to the draft, and third we have step draft. Direction to pull is again same, and my parting line is this one. But in the parting line draft, our draft angle is taken from the parting line, right? But in the step draft, our draft angle will be taken from the pull direction. So these all edges will be my draft edges, that hinge, that revolving axis, and it will create one step over here like this step. That's why this draft is known as step draft. You can step it inward also. Just flip the direction of this pull direction and hit OK. So in the step draft, that angle is taken from the pull direction. In the parting line draft, that angle is taken from the parting line. And in the neutral plane draft, your angle will be taken from the neutral plane and your draft face intersecting line. Okay, no problem. Parting line draft. I'm showing you parting line draft again. Go to the draft, take parting line draft, and select this face and select your parting line. Provide the draft angle and hit OK. We'll take a angle from the parting line, right? So this draft is parting line draft. Next we have shell tool. So shell that you already know, right? That we create many objects with the help of shell. So shell is mainly used for the removing material purpose from the inside of the solid and convert that object into thickened part or thick part. So here is your shell thickness. Provide your shell thickness and provide a removing face. See, if you are not going to provide removing face, click on the preview, and as you all see that our entire material from inside this geometry is removed, and all the face that this object is have will take 5 thickness only. But for example, some edges I don't want to provide thickness, so that type of faces you have to select over here, face to remove. So here I am selecting this one. So this face will not take any kind of thickness, and rest of the faces will take 5 thickness. Click OK and you will get this type of result. But let me do extrusion cut. Okay, so we have extrusion cut like this, right? So these are also faces, this one, this one, this one, right? So everything will take thickness over here. So click on shell 5 and I want to remove this face. Click on the preview. So see, this circular face is also taking thickness, this one, this elliptical, everyone will take thickness, and you will get as an output like this, right? But what if I want to provide some different thickness to some object? So for this face, actually I want 10 thickness. So here we have multi thickness setting. Go to the multi thickness setting, select your face, and immediately provide a dimension for that 10 So the thickness of this face is 10 Now I'm selecting this face and I want 20 Then for this one I want 7 For this one I want 2.5 and then hit OK. So these are the multi thickness geometry. The rest of the geometry will carry that 5 common thickness, but you can provide the uncommon thickness also to the faces, right? So now you will get the exact idea how to create geometry. In this one. So we have to step back in this extrusion. 90-degree angle we have. Nothing else. And height 20 mm. Okay. So from here we have to provide a draft. So click on the draft. Go to the parting line draft, and pull direction is this one, and parting line is this one, and angle is pistol is 45. Okay. Oh, no. Edit. Flip the direction. Okay. So it is fine now. Now do the shell command, but here we have a different thickness. See, here we have 30 mm inside diameter, and here also we have 30 mm inside diameter. So the thickness over here is 5 mm in this U band, but the thickness over here is 43 minus 30, 13 by 2, 6.5 mm, right? So for this we have 6.5 mm up to this point, then again we have 5 mm. See, so here we will use our shell tool. So click on shell, common thickness 5 mm, and removing face this one, and this one. Click on the preview, and uncommon thickness, that is this one, will carry 6.5 mm. But for that our this solution is not going to converge. Okay, for the 6 mm we are getting the solution, right? So just don't take that 6.5, go with the 6 mm. Still we are having problem? No. So yes, it is perfect now. So for this geometry we have, yes,
ఎక్కడ ఏడ్చింది
so it is clear now how to create this object. Okay, then next we have rib tool. So we are going to discuss about this rib tool again next. So rib is generally create for the support purpose. See, if you want to provide any kind of support, you can use rib tool. So let me take a draft, not draft, shell 5 mm, and want to remove these three faces, right? So we have this type of three geometries we have, and I want to create one support over here. So for that we can use our rib tool. So first of all I'm going to sketch it on the front plane. and there are many restrictions and constraints that you have to remember. Actually, there is one main thing. Whenever you create your sketch, right, it should be properly constrained, properly connected, and finish it and go to the rib tool. So this rib will create a support of solid geometry, and see, you will get this type of preview, and our material is actually going downward. Then just hit OK and you will get this rib, right? So here I am going to edit this. But to create a rib, you must have a constant solid on the other side. Again, to create a rib, you must have a constant solid on the other side. Hit OK. Then and then you will get a rib over here. Right? For example, we have a extrusion cut on this face, and let's say a very small or tiny thing we have like this, and this geometry, if it is going to come in our way, in the way of the rib, then rib feature will create an error. See, right now it is created. Okay, and let me edit it, and here we have a thickness, then alignment on the left, on the right, or on the center. So let me go with the left and check that. See, it slightly cover this area, right? Now try to finish this tool. See, we have error. Resulting rib did not intersect the existing model. Please try change, etc, etc. So in the sense, at the end you must have a complete solid on the other side. See, if you don't, if you have a very tiny gap over there, then also you will get error. If you go with the center thickness, then see, we have a result. Similarly, we have one more option over here, extrusion direction, that is parallel to sketch and normal to sketch. Now let me go with the normal to sketch. So it will go in that direction, like this, in this direction. Try to finish it. We have error, same error. So check it, what's the problem, and you will get that this corner is actually going outside, right? So let me decrease some thickness, 17.5, 15, and now it is inside, right? So again try to finish it, and still we have error. That doesn't matter, you have curved face or straight face or anything, but you should have a continuous face on the other side, right? If you have a very small gap over there, then your rib will not perform. You should have a continuous face, either it is circular or curvature or whatever types of face you have, that doesn't matter, but there must be something for the contact. So this is the another type of rib, right? So in this assignment 4, we have so many rib and fillets. So this is the example of draft. Yes, here you have rib. See, this one, this one, this one, this one, and this one. These are the ribs, right? So you have to sketch that rib. just create a line from this point to this point, then finish it. We have a continuous solid on the other side, so it will take that as a solution, right? Okay, so now if you have any question, then you can ask me. So our today's class is done. So how was our today's session? Do you learn anything new? Okay.
So, sir, I have a question.
Yes, please. What's your name first?
Abhijit Sarkar.
Abhijit. Yes, what's your question?
Sir, in this SolidWorks software, if we are doing a part design in 2020 premium version, then is it possible to open it in 2018 or 17 version?
Actually, we do not have any kind of facility to do that thing. See, let me show you again. On the software, I have both the type of version. This is 2017 version, right? And actually, we are going to create, save this file, and now I'm going to close this software. And here I'm going to open SolidWorks 2015. So see, this is SolidWorks 2015, and I'm going to open that from object. Where is that? Yes, assignment 3. Open. You will get this notice, right? That cannot
Yes, sir.
open this part. It's from future version. Okay. Now let me open SolidWorks 2017 also. We have one option over there, but you will lose your options. Whatever operations you have done, you will lose that. See, here we have sweep 1, then plane, sweep 2, draft, shell, and extrusion 1, right? So these are the operations we have done. This screen is visible, right?
Yes, sir.
Okay. So now go to the save as, and it's going to crash. Actually, I have turned on both the version at a time. Maybe that's why. Swift tool, yes, I will explain you, Ramandeep.
Sir,
So
saving it in
just
format,
save
I think
as
it's okay.
and choose a step file format over here, STEP step, and save your part in step file format, right? So step file is the file transfer format we have from one software to another software. And now you are able to open that step file in any software. Click on all file format, we have step file. You will get your result, but see, you will not get any operation over here. You will get your part in the lower version. It is visible.
We can do what we can't do.
Which type of color is this? Okay, right? But in the feature manager tree, you will not get anything over here.
We can't edit this sketch, right?
You can edit it. You will get all the dimensions and everything in the drawing view, but you cannot edit the existing feature. You can do your modification with the new features, like I want to add extrusion cut over here, right? I want to cut a hole from here and one from the center of this thing, 30 mm diameter, finish, right? Take extrusion cut up to next, so that holes and everything will be created. See, but you cannot edit this already created geometry because we do not have that features over here, like extrude cut we do not have the rest options, that sweep and sweep to that we have done. So are you getting my point?
Yes, sir.
Okay.
Yes, sir.
And sometime this thing is going to break also. Some many faces, like for example this face is deleted, or in this way you will get a broken piece also. So you have to fix it with the surface modeling tools. Like this, you may get this type of broken piece also. So you have to fix this thing. And if you have a threaded part, then never try to transfer that part with the step file to other software. Threads are mainly creating error in your geometry. So if you have a threaded object, then please don't try to transfer that. Okay, quickly let's we discuss that sweep tool. So here take a new file and sweep simulation, that actually I need to check it is there or not, right? So for the sweep we must have two sketches. One is our path. So for example, this is my path, and one is our cross section. So cross section must be perpendicular to our path, right? So if you want to create a perpendicular plane, that we also discuss, in the plane just click your curve and your point, and you will get a perpendicular plane. Then on that plane I am creating one more sketch, hexagon. and some dimensions relative to width curve. Okay. Make sure that your geometry, your cross section is small enough to travel from this band. If this cross section is bigger than this band, then it will create a self-intersecting geometry and you will get error over there. So go to this sweep, select your sketch and select your path, and you will get a sweep geometry. Right? We also have twisting profile option in this sweep. Go to the options. In the profile, go to the twist and provide the degree or number of revolution. Let's say I want to twist it 5 revolution. Hit OK. So this is twisted geometry. Right? So this is our sweep tool. Any other questions? Okay. So here is your assignment that we already discussed, right? So you have 3 components. First one is the little challenging one. So spend your time on the first geometry, then second and third are easiest. But create all these 3 objects, right, yourself. And see you in our next class. So I am going to end this call now. Yes, I will inform you that about the simulation. I will inform you. Yes, you can post your SolidWorks part files directly to us. You just attach your part file or components to the mail and uh, send that mail, upload that. Okay. Okay, no problem. See you.